The biggest opportunity I see is just that both sectors, transportation and energy, are undergoing huge transformations in the transportation system. We're seeing more and more EVs, and many companies have announced that by 2035, they won't build any new internal combustion engine cars anymore. As we go through a transformation, there's a lot of opportunity to digitalize things and to measure things more. And so wherever we have data scientists become valuable.
Hello everyone, welcome to the Data Scientist Show. Today we have Holger Teichgraeber. Holger is a data science manager at Archer Aviation. Previously, he worked at Convoy as a research scientist on their trucking marketplace and various companies in the energy space. Holger has a bachelor degree in mechanical engineering from Aachen, Germany, master and PhD with research focused on machine learning and optimization applied to energy system from Stanford University. He regularly shares his experiences on LinkedIn, and today we're going to talk about his career journey and how he builds valuable product at the intersection of machine learning and optimization in production. If you like the show, subscribe to the channel, give me a 5-star review, and leave a comment. Welcome to the show, Holger.
Yeah, thank you so much for having me. Excited to be here.
So how did you get into operation research?
Yeah, I got into the data science and operations research world from starting out with a bachelor's in mechanical engineering, and then in my master's and PhD got really exposed to the data science world and operations research because I was interested in energy systems and solving large-scale kind of energy systems problems. One of the methodologies to solve these problems is optimization, which is a core part of operations research. Operations research is basically a field that has been around for many decades and today can probably be seen as a subfield of data science. And then at Stanford just was able to take so many different classes in statistics, machine learning, computer science that really exposed me to the whole field. And that's how I got started in the field.
Yeah, I remember when I was in grad school, I studied statistics. At that time, there was no field called data science, and you either go into operation research or you become a biostatistician. So I feel operation research actually existed long before the data science, the typical data science work we do in tech. So what is the difference between operation research versus data science? What is the focus in operation research?
Yeah, great question. I think basically operations research can be seen as one of the many components of the data science field. There's the analytics part of descriptive analytics. We get data and we describe what we see and analyze. Then there's the predictive analytics part, which is we have data, we build models to predict outcomes. And then there's prescriptive analytics, and that's where operations research falls in, whereas we have data and we make decisions based on that data, or we make recommendations for decisions. And that's where operations research come in. For example, I have a classification model, especially the predictive part there is predicting a probability usually, right? But then going further, what decision do I make based on that probability? The simplest decision rule is I put a threshold there, and based on the threshold, I say yes or no. I'm doing either this or this. But in many cases, the business decisions that we have to make are much more complex and intertwined. And in these cases, operations research comes in. Operations research optimization in particular helps us understand if we have a complex problem, we describe the problem, the objective that we have, for example, minimizing cost, subject to certain constraints, right? I want to build a schedule for my school, for all the teachers and which classes they teach, with the objective of using probably their time most efficiently and other things. And then on the side, I need to satisfy certain constraints of someone cannot teach 2 classes at the same time, for example, or other things. And then I basically tell the model, tell the model, hey, these are the constraints, this is the objective. Find me the best possible solution out of all the millions over millions of combinations that exist. And that's where operations research comes in.
Got it. So you worked on trucking marketplace when you were at Convoy. Can you tell us more about the project?
When I worked at Convoy, so Convoy is a trucking marketplace matching shippers like Walmart or other big shippers with truckers, many small trucking companies in the US. And the goal was not only to match them on single loads, but rather to solve for the problem that oftentimes a truck goes from A to B and then goes back from B to A empty. And that empty miles results in obviously cost for the trucker, that's then handed down to the shipper, but also CO2 emissions that are unnecessary. And so can we build a product where we get people from A to B to C and then back C to A all in one round basically, and offer that on the marketplace? And that's what I worked on at Convoy. And there's really interesting problems in that space because we need to predict a combination of loads. How good will that fare in the marketplace? Which ones should we show to people in the marketplace? And that's basically a combination of a predictive problem. We're building predictive models and then building optimization models to decide what to show in the marketplace.
So I get after you build a model, just focusing on the recommendation, the likelihood of their acceptance, and there will be another layer thinking about the cost and then the revenue.
That's where kind of optimization for us put it all into one model, where we were able to build a model that says, give me the set of batches that maximizes expected profits, subject to all the different physical constraints of you can only be in this place and then pick up this truck. So we combine the physical part and the economic part in one.
Oh, gotcha. So when you work on this optimization problems, is it some package in Python you can use, or is there a specific tool you do it, or you calculate it on a whiteboard?
In Python, there are a multitude of packages to formulate an optimization problem and then solve it. I think like open source ones that could Pulp, for example, I can think of Pyomo. And then there's solvers that have their own kind of modeling packages. There are commercial solvers out there as well.
For example?
There's Gurobi and Cplex, for example, that basically allow you to model the problem in Python and then they're directly translated in the solver.
Oh, gotcha.
And there, maybe to highlight one of the key things of like optimization modeling and how it's maybe slightly different than on the machine learning side, is in optimization modeling, you have a model and you have a solver. You model your problem, you build a mathematical model, usually really literally in math. And then from there, you take it, you formulate it in a Python code, and then basically the modeling part is done. You send it to a solver. And if it's a rather simple problem or like a general problem that doesn't need much fine-tuning, basically the solver takes care of finding the best solution out of all possible combinations that this problem surfaces. And there's these two pieces to it. There's modeling and there's solving. In the machine learning world, for example, we often, I think, combine modeling and solving, where I'm choosing to do a tree-based model.
Yeah.
So I'm building everything for that kind of solution method. Yes, there's some tuning under the hood that may or may not be automated, but basically imagine the AutoML framework where you say, hey, I have this problem, give me whatever algorithm works well there. Just basically I'm formulating the problem, and then under the hood, the solver chooses how to solve it.
Yeah.
That's how in the optimization world, problems are formulated and then solved. You have the formulation modeling stage, and then you have the solution stage. And as a practitioner, at least in the initial stages, you abstract the solution part away and really focus on how do I best model my business problem.
Yeah. I see. So when you say you build a model and put it in the solver, what exactly do you put in the solver? Is it, say, the loss function of the machine learning model, or is it the hyperparameters you learned?
Basically, it's a math model. It's a descriptive model. So it's slightly different than a machine learning framework of modeling, where we're really describing what is my objective function. I want to, let's say, maximize revenue.
Yeah.
Subject to the constraint that, suppose I have a facility location problem where I want to say let's say we have electric vehicles and I need to decide, I'm Tesla and I need to decide where do I place my superchargers. So I want to then, in this case, minimize cost as an objective function, subject to I can place 5 chargers in this area, and I have a certain demand profile of where electric vehicles, for example, will drive around and charge. And so then I basically have the constraint that I want to satisfy demand for all vehicles within a certain time frame. I need to be able to charge them up. Things like that. You can describe it first in sentences, then you translate that into math, and that math is basically, that's the model. that can then be put into Python in equalities and inequalities. The number of cars I want to serve or has to be greater or equal than 1,000. The number of charging stations that I want to have has to be smaller or equal to 5.
Yeah,
and I literally write that down.
Yeah.
And that's the model. And that's what I send to the solver.
Now you worked at Archer. You support a lot of strategic decision making here, which is a little different from your previous work. Can you tell us more about what you do right now?
Yeah, very excited to talk about what we do at Archer. I'm there on the data science team at Archer. And what we build at Archer is we are designing, manufacturing, and operating electric vertical takeoff and landing aircraft that can fly up to 100 miles and up to 150 miles per hour, all with basically minimum noise. And the idea here is, suppose you are one route that we've announced is Newark to New York to Manhattan, a trip that can take you an hour, 1.5 hours usually. Imagine you can do this in 10 to 15 minutes with an aircraft that takes off vertically, then flies wingborne, and then lands vertically again. And so this field is called urban air mobility.
Yeah.
And we're planning for launch in 2025. So right now we're building the aircraft, but we're also planning to build an aerial ride-sharing service around it. And
that's very exciting.
Yeah, so that's where we as a team come in, because we need to decide if an aircraft takes off and lands within a city on rooftop on like a parking rooftop, for example, where should we place these? So you can hear like a facility location problem where we have all data of how people travel through cities, and we need to understand where should we place locations, and then how will these aircrafts be routed through the space. And so that's a lot of strategic decisions that we inform, because the company has to make big investments on where do we place infrastructure, where do we develop infrastructure, how do we support our network. And so that's where we come in as a data science team.
Oh, nice. Can you tell us more about some common problems you're working on right now? Like we previously talked about network planning and routing. I don't know if you can share a little bit about that.
Yeah, sure. We're trying to understand, how do people travel through cities today? And then how will they travel through cities in the future when we have this new service of urban air mobility? And so we take data on how people travel through cities today. You have in LA every day, for example, you have 50 million trips. A trip can be someone going to the grocery store, someone going from downtown LA to Santa Monica, to the airport, all of these trips. And we're trying to understand which ones are likely to convert into urban air mobility. So which ones have characteristics, right, that are amenable to saving them a lot of time, for example. And then based on that, we build models, lots of optimization models actually, on where do we place vertiports, the landing and takeoff locations in the infrastructure in cities, and then also how do we route aircraft through the city. And so, for example, for the location problem of where do we place infrastructure, there's billions of combinations of where we could which, if we want to place 10 or 15 or 5 or whatever number of infrastructure we want to put, basically there's endless combinations, almost endless combinations of how we could combine them. And that's where we build optimization models that can help us understand what's the best possible combination.
Yeah. And this is very exciting, and it's a new problem to solve. And compared to the trucking project you worked on, you previously had a lot of data. And for this project, you probably don't have a lot of data. So do you use simulation, and how do you solve the problem?
Yeah, it's a really interesting space, because previously what we talked about was all the operational problem. Now we are doing strategic decision support and trying to inform decisions that are really long term. Later on, we'll also be tasked with operations, but right now we're really focused on the strategic part. There's data out there on how people travel through cities. It's all anonymized, travel patterns. There's really good understanding that you can get from how people travel through cities today. And on top of that, then we can build models that can be based on surveys of preferences of what people would prefer in the future. And you can build models based on that. That's very common in the transportation industry. But in general, obviously, there's a lot of uncertainty and a degree of long-term kind of strategic thinking where we have to evaluate many different scenarios. But I think one of the key things there in these strategic modeling decisions is to really validate the inputs and validate them together with stakeholders.
Yeah.
Because if you can build a model where the inputs to the model are validated and people trust them, then you can basically build more trust with the output of the model as well.
Yeah. When you say you have maybe private jet, those type of data, I think a lot of aviation logs, because you're in a public domain, you can access it.
So yeah, I think that part of the data may be accessible. We actually look at quite different data because our aircraft are short range, up to 100 miles, but likely trips that we're going to do are going to be in the 20-mile range. And so we're talking Newark International Airport to Manhattan.
Yeah.
We're building a new service
Gotcha.
that helps people travel through cities.
Yeah.
And so it's really trip data in cities. Can we save them time? Is it like, do we provide value to them basically based on the new service that we introduce?
Are there any concerns about like air traffic? For example, when we're recording this, we have clear view, there's nothing in the sky, but do imagine there's going to be a lot of helicopters in the future.
Yeah, one thing to notice is that these are quite different from conventional aircraft and especially helicopters because they have 12 rotors, very small rotors. Small rotor means very little noise compared to a large rotor of a helicopter, for example. And so you basically won't hear it fly over. It's basically quiet.
Oh, cool. So in your current work, I assume you don't need to manage a large machine learning pipelines anymore, and you're working on smaller data set, but the decision you support has more probably economic impact. So how do you compare the big data science versus the small data science work?
Yeah, that's a great question. I think both have really exciting parts to it. There's the differences in the more big data world where you have automated regular decision making where things run in a pipeline, in inference pipelines where requests come in frequently. You're very involved with kind of fixing things that come up.
Yeah.
Versus now, I think in the more small data world, it's all about working with stakeholders, building trust with stakeholders, and building models that support their use cases. So it's maybe a little bit more targeted to specific, in this case, internal stakeholders, and building analysis around larger scale models that we have built internally, but then building targeted analysis for specific use cases. Where, at least in the world where I've been more in the operations side, it was large scale, like one big problem for a lot of different truckers, right?
Yeah.
And so I think that's where there's differences there that I find both worlds really exciting, because in one you support a lot of different users, and now we support stakeholders very closely, and so that's really exciting.
Yeah, I think the kind of big data world, machine learning, basically a lot of things what we do is automation. So I see data science work on different areas. Sometimes to support one important decision, you can work on just this one thing for 3 months. Like you mentioned, you really need to examine the data to understand the assumption. It's not like a machine learning model. You can maybe pick your samples a little bit and do hyperparameter tuning. And I think this type of role previously are more of the traditional statistician type of role before we had a big data.
Yeah, I think these type of roles are generally like more of what maybe before the word data science existed was statistics, operations research. And I think where the interesting thing where the maybe more big data science world is influencing these more traditional roles is that we can now also automate a lot of these processes. Right. So for example, for us at Archer in the data science team, we've taken a lot of these learnings that we have from the more automated pipelines and automating things into our world, where we've built models that are automated. They are served internally. We can basically automate a lot of the under the hood modeling and then just expose basically the analysis part. And so we've automated away almost a lot of our job to support more decisions and in a more granular way than if we were to build a model every time that we support a stakeholder, which I think the latter is maybe the more traditional approach from 20, 30 years ago.
Yeah.
And yeah, that's where a really large scale, like the larger scale big data influences these more traditional disciplines as well.
Right. Yeah. I know a lot of people, they get started in data science or machine learning because they love looking at the data. They also enjoy the getting insights, decision-making part of their job. But a lot of times if you work for a large company, sometimes you get sucked in of the process and most of your work become just one part of this machine learning pipeline, and it's very engineering heavy. I think having engineering skill is very important, but just to be honest, a lot of people, they didn't get into it because they're passionate about this part. I feel with your current work, you're learning those important skill sets like machine learning, engineering, but you still have time to explore getting insights from data, how to make decisions. I think that's a really fun job.
Yeah, it is. And yeah, you've summarized it actually pretty nicely, because also as a startup, right, you get your hands into everything. You do the engineering part, we build up the entire modeling system, but also deploying it. But then you also work really closely with stakeholders, which I think many data scientists are really excited about, to actually be close to the problem. We are often product people. And so being really close to the decision makers and understanding how they think and how we can support them is a really exciting part of the job.
Yeah. So how do you work with stakeholders? For example, how do you earn trust from them?
Yeah. Great question, because I think that's almost the most important thing that we can as a data scientist.
Yeah.
I think one thing is always think about how you can deliver value to them. So what is the question on their mind? Really trying to understand that. And oftentimes a stakeholder comes to you with a very vague, right? Or maybe they think they know what they want, but we really need to dig in and understand, okay, how can I help you? What's the problem at hand? And really ask questions like why, and really understand that. And if they feel that you're with a very humble attitude, right? You're trying to learn. They know so much more about their problem than you do, but basically coming there with a humble attitude, but with I want to solve this, I want to help you solve this problem. I think that's how we can build trust. And then quick wins, building something quick that shows them, all right, we're on the right path, and then step by step building trust through that. I think that's really important.
Yeah, I really like the 2 points you mentioned. I think a lot of times when data science came in, we assume we know more, we know better. I think it's important to also respect and learn the current process, what is working, what is not working, because if it exists for a while, or if your stakeholders fix it on a solution, there might be some element of it that you need to understand is important for them. Maybe you don't build the exact same solution, but you want to carry the benefit of the old solution to your new solution. And also, data scientists, we tend to dive into the data and build a product for 3 months. And then you realize that's not what the stakeholders want. And we're scared to show a model that doesn't perform very well. I think it's definitely important to show some early results, even if it's not working very well, to get feedback. And again, maybe you just, like you said, start with something simple. Maybe this thing is not a machine learning model. You have some rule-based solution based on your some assumptions. If it works well, it gives stakeholder confidence. And I think a lot of times we feel we started work on this project, we don't have to win over stakeholders anymore. I think it's a continuation of a quote-unquote selling process, because if they lose confidence, they might defund the project or change the priority.
Yeah, great point. You really want to engage the stakeholder throughout, and you almost it's this conundrum where you want to hand off your project, but at the same time you want them to be so excited about it that they come back and are like, hey, can we do this? Can we do this additional thing? Basically, if I hand off a project and the stakeholder never reaches out again, maybe they just go around it and never use it. And so it's really important to, as you say, figure out what are there, like small things that we may not understand fully, and build for them so that they actually use it. Because if we just build something for someone and they take it and put it in the closet, that's not what we want either. At the same time, we at some point want to hand it off and move forward with a new project. So how do you make sure that the stakeholder uses the model, the process, whatever we've built, can use it itself. That's really through the trust and through almost developing it together.
Yeah.
Where developing it together is really iterating on the problem, iterating on the solution together, so that the stakeholder really understands what it's doing, trusts it, and then moves on with it.
Yeah, I think that's a great point, because if you're building a machine learning project, you put it in production and there are users using it. But if you recommend a decision, you give a big presentation, you don't know whether you're using your decision or not. And I've seen those things happen when I was working at Amazon. Some team built some solution, and then but later on, when we asked them again, they didn't get adopted.
And one really important point there is, I think, in strategic decision support, what is our role as data scientists is not, in my opinion, it's not, I go to someone and say, this is the decision you should make, but it's more, I'm building a language that people can talk about. Because these type of decisions, it's usually not one person there looking at a presentation and saying, yes, this is what we should do. It's usually 5 people in a room, all from different parts of the business, all have different objectives in terms of what they are responsible for. And oftentimes there are trade-offs between these. And then we as data scientists provide a language to them to talk to each other, because they can say, what if we assume more demand in this area here? What if? So we give them a language, and then we can build the model and change parameters, change inputs to the models, and then provide, based on the outputs, they can have a conversation that is now quantitative, and that they can then make a decision based on. And so, us providing a language to stakeholders is, I think, a really important concept, instead of us providing one slide deck and done.
And also it's collaboration with them. If they feel they're part of the process, they're more likely to adopt it. And like you said, a lot of times you have different stakeholders and they have different opinions. How do you balance that?
Yeah, in the end, you want to support the business and the business objectives, and different stakeholders are responsible for different parts of the business. Oftentimes, there is competing objectives. And so I think for us as data scientists, it's important to recognize that we basically build sensitivities around each of these different maybe directions, objectives, so that people can then have a conversation around, if we go this way, that's the plus, that's the minus. If we go this way, that's the advantage, this is the disadvantage. And so then the decision makers can have a conversation around that and then come to a decision together.
Okay, so you basically translate the model of your, the output from your model into scenarios so they can talk about it. It's not just some parameters of a model. And I've seen, I forgot someone's video basically talk about how do you interpret a linear regression, the parameter. You don't, when you present it to the stakeholder, you don't tell them, hey, this is my linear regression formula. You tell them that this means if this variable increases 1 unit, we're losing $1 million or something. That's the storytelling, how you present to stakeholders.
Yeah, one of my friends in grad school had a rule for his presentations, and it was no math in my presentations, because it's all about the impact and what in the end, how it impacts the problem at hand.
Yeah, I understand you provide those scenario to stakeholder, and then they maybe meet without you to come to a decision. Has there been situations where they have different opinions, they also want your input? So do you feel it was difficult? Do you have to, say, pick a side or upset one stakeholder?
In the end, I mean, it's we don't need to make everyone happy. We need to make good decisions for the business. And so everybody in the room is a professional like that thinks that way, right? And we talk about the data, assumptions, and so on, and they may be more favorable for maybe one person's view and less favorable for another person's view. But in the end, everybody's a professional in the room and wants the best for the business. And so we're having a conversation around that. And that's how we as data scientists also can inform that, because we come with data. We don't come with just opinions.
Yeah.
We come with, hey, this is based on X, Y, Z. And with this data, this is how we can inform a decision here.
When we met at a meetup, I think you're a data scientist and now you are a manager. Was that transition? Do you still do hands-on, say, coding work? What has your scope changed?
I'm basically doing both individual contributor work, manager work now. So it's a really nice way, and I'm really grateful to my boss, John, who gave me like the opportunity to try it out, to see if I like the management of the job as well. Because I do really enjoy working with people, and I think there's one side is getting satisfaction from, hey, I built this really cool product. Another side is you see someone else that has really grown through your mentorship, through working together. And that part also gives me a lot of satisfaction personally. Yeah, the scope has basically changed in that I'm not only thinking about how do I build something, how do I maybe drive a project forward, but also I think about, is this person, can I provide them with projects that move them forward in their career? Yeah. Do I match that person's skill set with projects that
sounds like optimization problem.
Yeah, I mean, it's everything is somehow related to some optimization or decision problem. Yeah. Exactly. But it really is, how do I match skill set with projects that we have? How do I motivate people, right? Yeah. To bring the best of themselves to work.
Yeah, that's awesome. And now you become a manager, you have a different perspective when you look back at your career. You're a data scientist. So what were something you felt you could have done better?
Yeah, great question. I think one of the things is that, and maybe I wasn't super aware of that in the very beginning of my career, is in the ideal case, your boss should be your biggest advocate and your cheerleader, basically. Yeah. My job as a manager is that if someone performs well, obviously, then I'm there to support them and to help them in their growth. And so in that regard, as a data scientist, it's really important that I communicate clearly and openly with my manager what I'm interested in, what I want. Because as a manager, that's the only way that I can really help you or help someone as a data scientist, right? If I know what someone really wants, I can find ways to help them achieve that. And so really, I think like just an open communication and not being afraid of expressing aspirations. Yeah. I think that's a really important concept to keep in mind.
Yeah. So say if someone's on your team, say, hey, Holger, I want a promotion. Do you feel like, oh, why are you asking for a promotion? Or do you feel you can help them? So how do you approach this type of conversation?
It's the start of a conversation, right? Yeah. And so it's always good to have the start of that conversation, and then you can look back and say, oh yeah, what's the performance, and what are the goals, and what are the expectations for certain roles, right? Company usually has levels where there's expectations for, and as a manager you also have expectations for certain roles, and so it's a part of a conversation. Then I think there's certain areas that would be great to improve on, and I can point that out as a manager. I can help the person asking to then get there. Yeah. If they're there, okay, I know when the next cycle comes up, then I'll keep that in mind. Or if someone maybe is not performing that well, then it also opens the door for a conversation of, hey, how can we improve things? So it definitely is. That's the part of a job of a manager that's maybe quite different from being an individual contributor. And some people enjoy that part, and some people don't enjoy it so much. But it's really about the people and building relationships together and trust.
Yeah. I can see the passion. I can see you're not just interested in optimizing process and decisions, also optimizing people and relationships. I was asking the question because I recently taught a career course for data scientists. One part of it is about promotion, and I noticed a lot of students in my class, they are scared about having the initial conversation about promotion. They're worried that their manager will think they are not grateful or greedy, or they don't want to be pushy. They hope if they are good enough, really good, it will get noticed. And I think it's the other way around. I think you definitely don't want to say, hey, I want a promotion. You just ask when you didn't prove any track record. But it's you tell your manager where you want to grow, and then they help you find project with larger scale instead of just thinking about it and then assume you can work on some project and then get noticed. I think if you have a good relationship with your manager, it's always good to express that aspiration like you mentioned.
Yeah, and you can choose strategically as well, right? When you've performed well, delivered a good project, and then bring it up. And So maybe don't bring it up in every single one-on-one every week. I think that's maybe then a little bit too much. I think good performance alone is great, but then also having a conversation about that is even better.
Right. Even if your manager didn't think you're ready, you get specific feedback, and maybe your manager can help you improve the areas of your weakness. Yeah.
And
besides productivity on the data science side, do you notice I know a lot of company has shifted, they want to invest in and I talked to some data scientists in companies, they don't even know what is going to be the impact, they just want to develop some research investment into it. Are you going to find something? Have you seen this type of new interest in your company?
For us, we are really focused on building an aircraft. Maybe that's an interesting thing about being in startups, right? You are to some degree resource constrained to be really focused on goals that matter. Deep neural networks is really exciting and very applicable in many cases. But in many cases also starting small with a simple model is maybe the better thing, and then adding on top of that. And it's just, I think, focus on the problem, not necessarily the solution, I think is a great thing to keep in mind. It's definitely something that I think had to learn over coming out of graduate school into a job, that it's really important that the problem comes first, not the solution.
Yeah. For data scientists who are interested in the energy industry, can you share what are some topics they need to read about?
Yeah, I think, and I'll expand it a little bit to both energy and transportation. Maybe that's the area that I'm really excited about. There's great blog posts by Uber, DoorDash, Lyft that talk about what models they build, what data science models they build, but it also talks about the problems that these companies are facing. And that then really helps, I think, dive in. And as people read these blog posts, then one can ask oneself, why is this? There usually are more questions than answers out of these readings. And just dig in, maybe talk to someone, ask them about the problems that they're working on.
Yeah. I think it doesn't matter how advanced the technology is, we still need to buy food. We need to go to places. So I feel the transportation and energy industry is a very crucial part. It has been around for a long time. It's definitely not always like the newest, hottest thing, but I think it's an essential part of our life. So what are some opportunities you see there?
Yeah, I think the biggest opportunity I see is just that both sectors, transportation and energy, are undergoing huge transformations right now, in the past 5 to 10 years, and in the next 5 to 10 years, because we are the energy system, we are in California, we are transitioning to a low CO2 energy system. In the US, all over the world. So there's a huge transformation. In the transportation system, we're seeing more and more EVs, and many companies have announced that by 2035, they won't build any new internal combustion engine cars anymore. And so there's second and third order effects. If you only have EVs, you need a lot of EV charging stations.
Yeah.
Where should you place them? There's tons of data on how people charge. And then you place these charging stations, you need the power grid that supports these. How do you build that power grid? How do you not completely overload the distribution system? There's these second and third order effects that come with these large trends that I think I'm really excited about in both industries, and I think that are ripe for a great career in transportation and energy for many people, also from the data science world. Because as we go through a transformation, there's a lot of opportunity to digitalize things and to measure things more. And so wherever we have data scientists become valuable. Yeah.
And I think especially if you're a type of data scientist, you like doing machine learning, optimization, and you are interested in a broad range of kind of topics, and you don't want to lose the kind of getting insights, strategic planning part of the data science. I think this is a great industry to be in.
Yeah, and you need to kind of work really with the product side of things as well. I think that's where I think these sectors are really interesting, where just being a data scientist that crunches numbers is not enough to solve the problems.
Yeah. So previously you worked in Germany. What is the culture in Germany and US, especially Silicon Valley, in terms of working?
It's really interesting to see how work cultures are different in different countries. As a side note, I should probably say that I've worked much more in the US and in Silicon Valley, especially than in Germany. But I think one of the main differences, and it's often said about Silicon Valley, but I think it's really is true, is that here you iterate very quickly, you can fail, and you get a second chance, and you get a third chance, right? I don't know, I think like the founder of Uber, for example, like his first startup didn't work out, the second one I think went a little bit better, and then the third one I think went really well. But getting that second and third chance, that's something that's really, I think, almost unique to Silicon Valley. It's much, much harder in Germany, for example, and that really drives innovation. On the other hand, in Germany, things are very well planned and then very well executed based on that planning. And so Germany's known for really great engineering products. And I think that's because the execution and planning is really well thought through. And so the products just work really well versus this Silicon Valley fail fast or move fast and break things. That's an attitude that leads to quick innovation. But if you deploy it at scale, you have things that break as well.
Yeah.
And so the user experience may not always be perfect. And so there's a balance between two, and both, I feel like both work cultures have their advantages and disadvantages.
And now you bring the rigor and planning to the Silicon Valley culture.
I'm not sure if or maybe I've adapted the move fast and break things as well, but definitely I do think that's the interesting actually thing about having diverse teams. It's like you have people from all different types of backgrounds. Everybody brings their own perspective and experiences with them, and that's really how you then build products that serve a diverse set of use cases.
Yeah. So you have supported a lot of important decisions and maintained machine learning pipelines. What was a challenging time when you felt really stressful, and how did you overcome it?
I think usually tight deadlines or having to deliver something when or when there are multiple projects at the same time that you have to handle. I think that maybe is even more stressful, where you have to then, there's 2 or 3 different projects, they all need to be delivered, important, and so then how do you prioritize between them? Because I think one thing is to set expectations ahead of time. If something is maybe behind, mentioning that, not trying to move that under the rug and then last minute say, oh, sorry, this we can't do this. And so I think really, managing expectations ahead of time maybe is one of the most important things there, because that then helps you also set expectations for yourself, right? Instead of setting these really high expectations on all projects, maybe you figure out that through that conversation, someone says, oh yeah, here, this one project, I've had this, this is actually, we don't need to do this within the next 4 weeks. So, all right, good, let's do this afterwards. So you're really talking about the priorities then. So that's one thing. I think the other thing is also having a life outside of work is also good to manage stress. Doing a workout, just all kind of things that are outside of work can really help set the mind. Going for a walk sometimes helps solve a problem better than sitting in front of the computer for 8 hours. Yeah,
that's a great point. And also sometimes we feel the deadline is set for us is fixed. A lot of times it's direction. Maybe it's set by your manager or your product manager. And I think a lot of times we have the fear to tell people, hey, we can't meet a deadline. We just hope people will forget about the check-in day, but then people ask you, and then you've been put in the position is passive. So having those conversations proactively helps. Yeah. And what is some important feedback you got from someone you work with or a manager?
Some important feedback that I think I got that's really, I think many people share is that estimation of timelines, for example, right? That's like, all right, I can do this in a week. Yes. And then you realize, oh, this is a much bigger project than I thought. So I think that's really something. And I see this a lot around where basically I think as data scientists, as engineers, we are very optimistic oftentimes in our estimations of how long things take. And then, oh, this is actually more complicated than I thought. Right. And so I think that's just something general to always be maybe a little bit conservative in the estimation of how things take, because we're excited about a project, we want to get it done, and then so optimism comes in, which is great. You want to move fast, at the same time being realistic around that. Yeah.
So now have you learned the parameter to multiply your initial planning time?
I'm not sure if I've mastered it fully, but definitely, yeah. There's actually, I remember someone told me once, always multiply things by 3. And I don't know. I don't think that's necessarily the most accurate advice. It's definitely something that I think in the oftentimes help to actually to have a parameter there. Okay, this is my initial estimate. All right, I'm going to multiply this by 2 or by 3, depending on the complexity of the project.
So what do you think about the next big challenge for data science teams?
Yeah, I think it depends a little bit on what type of data science team, obviously. I think maybe in a research setting, there's a lot of things going on with LLMs and generative AI now that will swap over time also into maybe smaller companies, smaller teams, or more maybe product-oriented teams. At the same time, I think in general, there's been a trend, and I think it will continue, where more and more data scientists move from the classic Jupyter notebook into a more automated pipeline, becoming a little bit more engineering heavy.
Yeah.
I think it's something that has happened in many data science teams already, but there's also quite a few where maybe that's still ongoing. And so the more and more people, like more senior people, have both data science and engineering background, that will disseminate into data science teams, I think.
Yeah. And right now in your career and in your personal life, what is something you're excited about?
Yeah, I think I'm really excited about the future of energy and transportation. I'm just very excited what's going to happen in the next, 5-10 years. And yeah, just a hockey stick where we're at the beginning.
Yeah. Cool. Before we wrap up, where can people find you online? Do you have a blog besides your LinkedIn?
Yeah, I mostly write on LinkedIn. I write at the intersection of machine learning and optimization and how to put these into production. That's the areas that I'm really excited about. Building models and building them so that they work for stakeholders. And so I try to write at the intersection of academia and industry and how people can navigate that space of building models that work in production in optimization and machine learning.
Great. I really enjoyed our conversation. Thanks for coming to my studio, Holger.
Yeah, thank you, Diana. I really appreciate it. It was really wonderful to have this conversation. Really enjoyed it.